Hello and welcome to Lecture 14, Part 2. So we are talking about inheritance, right? Once again, talking about features in the Scala language, how we can use it to make better, more reusable hardware designs, right? And so we covered some techniques for inheritance in Scala so far, things uh, like doing simple class inheritance. We talked about abstract classes. We looked at Scala's collections. Um, and so we did a simple example. And now we're going to do a slightly more sophisticated example, right? So let's say we want to build this library where we have these decouple operators. These operators are decoupled. They, have a decoupled interface on their inputs and outputs. Internally, they actually also will have a register to actually buffer their outputs. So that way, the critical path is only one operator long rather than multiple operators. You can imagine building up a circuit of, a number of these operators and kind of, with full data flow operation, getting very smooth, elegant execution, right? And so what we want to do is we want to cap as much as we can of what it means to be a coupled operator inside this parent base class. And then we're going to have some child class actually implement features, right? So here's the parent class, right? Which we happen to define as an abstract class, meaning, you can't instantiate this directly. It needs to be instantiated as a child that extends this class. And yeah, so what do we have? Well, we have our inputs A and B, our outputs C. So yeah, we're inducing sort of operation. It takes an A and B and produces C. That's the goal. These are all decoupled. And so yeah, so the operation we're doing, not specified. It's going to have this name op. That's where we're kind of defining it. But as you can see, there's no body to this method definition. This is an abstract class. You can do that. And then, in the child classes, you actually will instantiate and explain what that is. In terms of what's inside the actual body, we have a buffer to hold the output. We're also going to have a bit to know if we're full or not. And basically, if we're full, we're not taking anything. But if we're not full, then sure, we're ready to take inputs. How is our output valid? Well, only if we're full, meaning we have something there. And then, uh, you know, the output, of course, reads out of the buffer. And then, yeah, if our both our inputs fire and we're not full, then sure, let's perform the operation and put the result in the buffer and mark itself to full. And once our output fires, we, of course, will mark itself as not full, i.e. empty. So cool. That all fits together. Questions so far? Let's try doing something with it, right? So let's say we want to do an add. We can go ahead and extend that class we just made and say, hey, I want to do add. I'm going to define the operation. So we take in these two things. We're saying the operation is going to be add. Likewise, we want to do subtract. We can, define the operation to be a minus b. And then, of course, we can put all this together in a factory, which, can simply take in a string for the operation they want to do, and this automatically will return the right object for us. And notice how, adding more operations is really easy, right? It's just basically a one-liner for each new operation, and we're able to reuse all this other code, right? And so it all kind of fits together. Also, when it comes to things like testing, we can reuse the interface for all this, and it all fits together because it's all designed to work against the coupled operator. And so even though it's different child classes, they all can reuse the same testing harnesses, right? So yeah, you can see that, of course, the Verilog, we've done this all quarter. We actually were to run the test itself. Um, sure, yeah, we can do that, right? As cycles count through 0, 1, 2, 3, 4. We're adding them up. We can see looking at the output, for example, when's it valid? Oh yeah, we had 0 and 1 and we got a valid response. Later on, we added 2 and 3 and we got a valid response. It's working. Cool. Questions? Um, so far we've seen, using extending a class, and we said, what, sometimes you can extend an abstract class and making the base class abstract. We have some sort of simplifications possible by not define everything, and we can kind of make it clear this thing shouldn't be instantiated and say you got to instantiate one of the child classes. But you remember of all that inheritance we talked about so far, we said you could not inherit from multiple things, or only can inherit from one thing. So what's the solution if you need to inherit from multiple things? It's called a trait. So a trait isn't quite the same as an abstract class. It has certain capabilities and certain constraints, right? And so the capability we're most excited about is it's more flexible. You can inherit from multiple traits. So you only can inherit from one class, but you can inherit from multiple traits. Sometimes you hear the term is referred to as mix-ins, as in you can, add some functionality to your class. So rather than thinking of your class as a specialization of some base class, it's more by using a trait, you're kind of mixing in some functionality, right? Um, and so that's kind of what you do. You kind of add little stuff in. And so what are some of the trade-offs of traits? Um, number one is that you can have from multiple of them, but there's some constraints. For example, it doesn't take constructor parameters, right? So there's none of that kind of stuff in there. It's kind of a way just to inject some functionality into your code. And you'll see that in Chisel is actually a really useful thing to have. So even though abstract class and trait both exist, there's kind of these, overlapping but also somewhat distinct features between abstract classes and traits, and that's why Scala has both, and also why we'll probably use both in our Chisel designs. So uh, let's say, for example, you want to add some functionality to modify your module, right? So let's say you have a module like counter mod down here that has a counter inside, etc. But what if we want to have a more standardized way to print with them? So in this case, I'm doing prints to the console, but maybe you have some sort of logging system or something like that. You can imagine whatever it is. So wouldn't it be nice to have functionality that's kind of reusable across all sorts of modules? So you're using it in one module, but imagine we have a lot of modules in our design, and we all want to kind of leverage this same printing functionality. So what does printing functionality do? Well, if it's enabled, it's going to, when print enable, it's going to print a message. This is only working simulation, of course. You can't do a printf on a real hardware design, but this is still useful. And you see as a trait, like an abstract class, we can have some of these fields defined, but not fully instantiated, not fully described, just kind of declared. Um, so you see, oh yeah, we'll print this message. And then in this counter, you'll notice that, okay, the counter itself takes no input, but it has some output. And yeah, we have output, we have a counter basically continuously counting. And we also mixed in this print and sim, right? So rather than extends, it's with, right? So we're mixing in this trait. And then, oh yeah, for we need to find message, we do that. And we can see, oh yeah, so if initially if we have the counter, the printing set to false, it doesn't do anything. But then if we turn it on, it'll print, right? And we can see that, for example, this dot print enable field isn't directly visible here, right? It's because it was mixed in by this trait print and sim, which has this IO print enable. Yes. Is bundle a trait? Yeah, that's a good question. I thought bundle might have been a module, but I'm not sure. So let's see if we can't find out. Um, so here we are navigating to our standard library stuff. Why don't we just search for bundle? Bundle is an abstract class. So it's not a trait. But the reason why I checked this is there was a possibility it could have been a trait. That could have been a reasonable design choice, right? That could have been a way this thing could have worked. So that's why I had to check it. But yeah, good question. But there are plenty of other times to use traits. And so uh, this example shows a few things. Number one, the niceness of a mix-in, right? We just added, with print and sim. Perhaps we need to add some extra fields to kind of get what we wanted, but maybe we didn't even need to do that. And we get this functionality added to this module, right? Our module now has functionality that came from other code, and this is a great way to kind of reuse code across modules. So that's cool. Um, does anybody see any potential challenges with this? Let me give you a hint. Let's say uh, you're reading code scrolling through, and you see this, and then you see this, but you don't know where this came from, right? Yeah. Oh yeah, great point. So good suggestion was, wait a second, this trait is adding an IO to our module. Like that's, a concern. And also, what if that uh, name conflicts with the stuff there? Great concerns. So someone's got to make sure there's no name conflict. But yes, it's adding to the IO. And then more generally, what I'm getting at is this is something that's not just specific to the chisel, but when you go really aggressive with object-oriented inheritance, or in this case, using mix-ins with traits, um, there's a balance needs to be achieved. Like I showed you earlier, functional programming going too far can sometimes be hard to read. The same thing's true of object-oriented programming, right? If the whole point of objects is to encapsulate complexity, right? You put things in the object so that way you can just use the object not knowing how it's implemented. However, like here, we're adding this thing to our module, and then it's changing the way for someone to interact with this module. And if they don't, you know, recognize this keyword over here to like where the heck is print and sim, they could even, potentially grep on the file for counter mod and never even find print enable, right? And this happens a lot with object-oriented programming, where if you extend a lot of things that's really buried really deep inside the inheritance path, it's sometimes less readable, right? You have to check multiple files. This is, reason, lost count, reason 15, why I keep recommending using the IDE, because the IDE, you can hover over print enable and say, go to declaration. And you say, wait a second, I'm not going back to counter mod, I'm going to some other trait, right? And so this is the kind of thing where having that language server or an IDE really is going to help you. But to the question earlier, what happens if we uh, have a name conflict? I'm really curious. Let's find out. How print enable is a type mismatch. Well, it's good there's an error because it shouldn't have two people assigned to the same module name. I'm not sure this is given this error message, I'm not sure you'd figure out this is the cause. But so somehow it seems like this one won out and it was first, and now it's doing it a second time, but it's still a little odd. But yeah, that was me trying to break it. So mission accomplished. It broke. Question. Yeah. Well, yeah. So that's a good question. Let's see if I try to define print enable just equals something totally different. What's going to happen? It's a similar behavior where you can see where it's actually kind of a little interesting to me. I actually don't have a perfect answer from my understanding of Scala, but here we have effectively two vowels with the same name in the same namespace, right? And somehow this is causing it to say the types don't match rather than saying you're redefining a vowel. And we've seen from before, like with an object, in a regular inheritance, class inheritance, if you redefine something, you need the override keyword, right? And then if something from an abstract class, you do not need to have the same name. So my guess is this is behaving more like an abstract class in the sense it allows you to redefine things that already exist. However, I guess it's in order to maintain that interface the trait provides, it's requiring types to be consistent. In this case, types are not consistent, right? So you can imagine, if I uh, instead of making this four, I said, man, we're breaking the kernel left and right. I don't even know how I did that. Okay, cool. Um, so that's not no. So you can see where it breaks the compiler process. The first, the compiler checks the types didn't match. Now that the types do match, it's complaining that the names I'm redefining. So I would need to override explicitly. So yeah. So to answer your question from a minute ago, yes, it seems that the traits and mixins are treated like inheritance from a class, in which case you need to explicitly override if you want to take it on. Great question. Yeah, this is kind of curious to play around with this kind of stuff and see what happens. But you can see the bigger picture here is you have all these mechanisms available to you as a developer. And the goal is how can I use these method codes simpler, easier to read, more robust, etc. But complexity unmanaged can make life hard on everybody. Um, so talking about that complexity, let's talk about all the object-oriented mechanisms we've covered so far in this class. And the sad part is this is not all available in Scala. So when I said Scala's rich language, I was not kidding. So we've talked about classes, right? We've talked about objects. We've talked about case classes. We've talked about abstract classes. We've talked about traits today. Good news for us. No more. I'm not covering any more in this course. So this is the final list of object-oriented concepts we're covering in this course. So let's recap, right? So class, we use this a lot, right? It's a regular class. We commonly use this. You can instantiate classes as many times as you want. And a lot of things that we think of as chisel components are really just us inheriting from a class. Things like modules, bundles. We just talked about this, and apparently my own slides sort of told me of bundles and inheritance. Um, we've covered those, right? Objects are a singleton object. Sometimes it's a companion object to a class. We've seen that. And so we like this for a number of things. Sometimes it's helpful to put, stateless code just put together someplace. There's some constants in there, sure, that's also helpful. It's also a way to get multiple constructors. You can have factory methods, factory pattern. We've seen that. And then, in this lecture between part 1 and 2, we've seen some other things. For example, case classes we've already seen in this course. They're a restricted type of class. They can't do everything a class can. However, that restriction comes with some benefits. You get some things like copy constructors. You get the ability to do printfs. You can do pattern matching on them really nicely. They do a lot of things well. And so we've found a lot of mileage in Chisel for case classes with things like parameters and pattern matching. And then for us doing our own object-oriented inheritance, if you want to make something and then you want to have a specialized version of it, traditional class inherit works great. If you have multiple things, they're going to share a lot of code, but they're all kind of peers. There's no clear parent. That's where an abstract class comes in. Where you can kind of have this single shared code, but it's not directly instantiatable. You got to have these, childs that actually implement it. And then, of course, we've covered traits, and so you can use things like mixing in. So to give you an example of a really advanced use of a trait, um, there's something called Rocket Chip, which is a system-on-chip generator written in Chisel. And it has this really cool thing called diplomacy, which allows different components in this SOC to plug into each other. And as the code is running to do elaboration and generation, negotiate parameters. So for example, let's say you have multiple IP blocks on a bus on your SOC. The IP blocks need to figure out who gets which identifier on this bus. And it's kind of a peer-to-peer conversation that'd be nice to do at runtime. And so with diplomacy, you can mix in the diplomacy functionality into your module, and now it has the capability to speak diplomacy to other things. So that's, I think the poster child, the most sophisticated use of diplomacy I'm aware of in Chisel. I'm sorry, of a trait in Chisel. Um, and it's helpful for a lot of things. And so, yeah, maybe you'll find something for like debugging or testing is helpful. Like I said, maybe you want to have something for logging in your project, and traits are great way to kind of mix that in. Cool. Questions? Okay, then, you know, as an additional detail, we're going to cover this. How can we have generics? That is, have templated types in our system. We really want to make our code more usable. Why don't we template types? Um, a lot of languages have generics. The generics in Scala have two things that may not be something you've seen before when you've done generics in other languages. Number one is something called a type bound, meaning rather than just letting any old type, if you want to have a rule such as I'm willing to take in any type for this thing as a generic, as long as the type is a subclass of X, you can do that. Um, the other weird wrinkle about templating types or generics in Scala is something called type erasure, which is actually a thing that can be traced back to the JVM and actually Java. And I'm quite critical of this particular issue. I think it's one of these things where it makes code really confusing for people. Uh, and it behaves in a way that's surprising. And then, we don't like surprising when it comes to coding. The justification for this is that, choices were made many years ago for Java to have JDK 8 compatibility. And those choices were persisted in Scala. And I think Scala could have made different choices that were more clear. So if you want to see what type erasure is, you can go ahead and click on the link I put in the slides, go read it on your own time. Long story short, there's situations where you can write code that looks totally like makes sense. You're doing pattern matching on types with a generic, and shucks, can't do that because it turns out the Scala compiler discarded information about which type is which. And with the link I provided, it has some information about how to do some additional imports into your design, so that way it actually tells Scala to track types of actual what's called a type tag and fixes all this. But that all sounds really complicated. I agree. It's really complicated and it shouldn't be exposed to programmers. That was, to me, a real wart in the language. And it's not a total coincidence. Apparently, the person who had a solution for Java is also the Scala creator. So the same sin keeps compounding. Um, Now, let's see template types in Chisel. This is the most canonical thing you're probably going to do, right? You're going to have your module, and then this is Scala style. You have square brackets to indicate the type parameterization, and like a lot of other languages, type parameterization, you don't always have to label everywhere. There's some, carrying over in type inference. In this case, this is a very common pattern in Chisel. You actually have both a type parameterization and you also pass in the type. Now, the reason why that's the case is that uint, even though we treat it like a type in Chisel, it's actually an object, right? So it's actually not a type, it's actually an object, right? And so um, we have this notion of a generator which produces instances of a certain type. And so, yeah, that's kind of what we're doing here. But language semantics aside, you can kind of do this boilerplate, where if I want to have a type that comes into my module, say I want to use that type for the input and output, I can pass it in like this. And so, yeah, here I have this set up. I have a question already. Yeah. So I say uint 8 like this. I'm saying that's the type I'm passing in. So for Scala, normally for type parameterization, you would normally pass type in like this. But the way we set it up, we're doing it the way I've shown. So, for example, here I have it as, an 8-bit uint. We've seen changing widths all quarter. I can easily change that to an essent, which at this point doesn't really change anything, but also, of course, could do things like, a bool, right? They're all the same. So if I go to the next slide, you can see the type hierarchy within Chisel, and you can see that, data is the most general. And so for a lot of times, data is the right answer. So you can see if I go back a slide, there was a type bound here, and it says whatever you pass in as a type here needs to be a child of Chisel data. And that's a good choice for much of the time. But maybe it's a certain application where you want to be more restrictive. Maybe you don't want um, it to be so broad. Maybe you want it to be a number or bits, right? And so you can see how it's more restricted, right? Data includes both vex and bundles as well as uints. There's kind of more specific ones as well. Cool. So then if we could take our trusty queue from before, now for the last step, we're going to go ahead and template our, type, and that's it. This gen appears in a few places, and now QV7 is what we always wanted, right? It's uh, type parameterized, has all the flexibilities we're hoping for. Uh, you know, no problem for me at this later stage. Just say, give me an essent or something. Oops, that breaks my test bench, but not the generator. And so it's good for me to be aware of that. Actually, wait, no, I should will change it. Actually, I gotta change it here and here, and it might still work. Nope, because the test bench has .u in it. So my test bench is not parameterized enough. I need my test bench type parameterized, but the generator itself is type parameterized. Cool. Okay, any other questions about inheritance or type parameterization? So I have a few slides here on suggestions for the project, and I can go over them now. But also, of course, I encourage folks if they aren't present or don't have the aren't watching live to answer today, come grab me in office hours next week. As a reminder, a week from Monday, we're going to need your project proposals. You're going to upload a PDF on Canvas, and from there, we're going to have our project meetings the following that week, on Tuesday and Thursday, to talk them over. So, big picture, right? What's the goal of the project? You're gonna, is it, as a pair, or if you really need to alone, but recommended a pair, you're gained experience developing or revising a generator, right? So you're gonna propose something, I want to build a generator to do X, and then you're gonna go about building it. Remember, it's kind of a progressive step. How do I think of the most simple, smallest thing to do? How do I kind of incrementally keep extending it? How do I test it? How do I make it flexible enough? How do I make it better in various ways? And so, oftentimes I get questions from students about how to pick a project, and I usually say, start with things you're familiar with, right? Things, your applications or domains you're really interested in. If you start there, you already kind of have some knowledge about that domain. But then again, if there's something new you want to try out, feel free to, right? I've had plenty of students kind of use this project opportunity to kind of learn something new. So that's totally fair. The things I want to see in the project is your generator is not just a single fixed function unit, but it has some sort of parameterization to it. You can change some knob, turn some knobs on, and make some sort of generation about it. Additionally, it's kind of good to pick the right size project. It's very easy to have something that's too small or too big, and this is a good thing to have a conversation with the instructor about to make sure it's the right size. One of the things that's nice to have when you have a project, if possible, is I call incremental progress. In other words, a project where you know it takes 4 weeks for this project. It's not always clear from the beginning before you started what's going to be possible or how fast you're going to be able to build it, right? And so I like to have projects where if you have a really rough time, you only get a small fraction, hopefully get working. There's still something there, rather than, shucks, it doesn't work at all, and there's nothing to show for it. At the same time, there's room for if you do really well to kind of keep adding functionality on that can make it bigger and deeper, right? So have it some kind of as a ramp, where it's, the bare minimum is still interesting, and then you can make it even better still. Um, Now in 2025, there are quite a few projects out there, both from this course and elsewhere. So yeah, look around the web, make sure, has this been done before? Has this been in chisel before? If so, it doesn't mean you can't do it. Just try to identify how yours will be different and how you'll do something new. Um, and when you write a proposal, one of the things I ask a lot of groups about is how do you get started, right? What's gonna be the first thing you build? What's kind of simplest, smallest things? What's your roadmap for kind of, defer functionality, eventually get there eventually, and stuff like that. Questions? Okay. Um, some past projects felt kind of interesting to share. Like I said, we've seen all sorts of ciphers and hashes over the years. I normally am a little bit hesitant about some of these because, like I said, a lot of these are very fixed function. They're not really good generators. When we've had better projects in the space, it's been because students have been very clever about how to use the generation methodology to implement a hash in a way where the code, rather than being lots of copying and pasting or lots of constants, actually like is constructing it in a much more verifiable, elegant way. But I've seen a lot of these projects and they can be good, but I prefer if people keep looking. We're also been out there. We've had people do all sorts of things for AI, of course. We've taken neural nets and then turned it into hardware. People have built components for AI accelerators, for example, like a systolic information location unit, like in the TPU. People have built Bloom filters. Sometimes people build things that are just for fun that don't even make sense in hardware, like building a Mandelbrot fractal generator. In other words, I computed all these bits for a fractal and had a way to visualize that. But even though that hardware software interface didn't necessarily make sense for real world, it was fine in simulation. It was kind of a cool project. So that was fun. People doing sequence alignment for DNA, Smith Waterman, things doing AV. We've had people doing video, images, audio, all of that. So a lot of things are possible. If you haven't already, maybe talk to staff about your project, and that sounds good. And find a partner too, of course. Cool. Any last points? Okay, let's end that lecture.